will it help me to generate a lift? How do I know lift is generated? Simple question, simple answer. If the fluid is moving only in the downward direction, okay, there is no motion of the fluid in the upward direction, I am generating the lift. Do you agree? ನೀವು ಗಾಳಿನ ಕೆಳಗಡೆ ದಬ್ತಾ ಇರೋದು ಮಾತ್ರ ಕಾಣಿಸಿದ್ರೆ ಅದರ ನ್ಯೂಟನ್ ಲಾ ಪ್ರಕಾರ ಆ ವಸ್ತು ನಿಮಗೆ ಮೇಲ್ಗಡೆ ಫೋರ್ಸ್ ಅನ್ನ ಕೊಡುತ್ತೆ. ಹೌದಾ? ಇದು ಫ್ಲೂಯಿಡ್ ಮೇಲೂ ಹೋಗುತ್ತೆ ಕೆಳಗೂ ಹೋಗುತ್ತೆ ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಟೈಮಲ್ಲಿ ಯಾವಾಗ ಮೇಲೆ ಹೋದಾಗ ಫೋರ್ಸ್ ಕೆಳಗಡೆ ಬರುತ್ತೆ, ಫ್ಲೂಯಿಡ್ ಕೆಳಗಡೆ ಹೋದಾಗ ಫೋರ್ಸ್ ಅಪ್ವರ್ಡ್ ಬರುತ್ತೆ. ನಾವು ಅಪ್ವರ್ಡ್ ಹೋಗೋದು ಫೋರ್ಸ್ ಮಾತ್ರ ಬೇಕು, ಕೆಳಗೆ ಬರೋದು ನಮಗೆ ಬೇಡ. ಆದ್ದರಿಂದ ಯಾವ ಥರ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ಈಸ್ left side we have made a symmetric flapping where you see fluid motion both in the upward direction and downward direction. In asymmetric flapping where I go down little fast, come up slowly, I get only downward motion of the fluid. And while doing that we identify for a kinematics, that means what is the ratio of the downstroke period to the upstroke period, wherein which I can get only downward jet, not the upward jet. ಅದನ್ನ ಲಿಫ್ಟ್ ಜನರೇಷನ್ ರೀಜನ್ ಅಂತ ಕರೆದಿದ್ದೀವಿ. ಎರಡೇ ಎರಡು ಜೆಟ್ ಬರುತ್ತೆ, ಕೆಳಗೆ ಹೋಗ್ತಾ ಇರೋದು, ಮೇಲ್ಗಡೆ ಯಾವುದೇ ರೀತಿಯ ಜೆಟ್ ಬರೋದಿಲ್ಲ. ಅದನ್ನು ನಾವು ಲಿಫ್ಟ್ ಜನರೇಟಿಂಗ್ ಪೀರಿಯಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅದನ್ನು ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಒನ್, ಇದನ್ನ ಡಿಟೈಲ್ಸ್ ಐ ಡೋಂಟ್ ಗೆಟ್ ಇಟ್ ಗೋ ಫಾರ್. ಇದನ್ನ ಸಿಮ್ಯುಲೇಷನ್ ಸಹಿತ ಮಾಡಿದ್ದು, ಅದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಆಯಿತು. ಇದೇ ಥರ ಸಿಮ್ಯುಲೇಷನ್ ಸಹಿತ ಮಾಡಿ ಇದೇ ಥರದಲ್ಲಿ ಎರಡು ಜೆಟ್ ಮೇಲೆ ಹೋಗ್ತಾ ಇರುತ್ತೆ, ಎರಡು ಜೆಟ್ ಕೆಳಗಡೆ ಬರ್ತಾ ಇದೆ ಅನ್ನೋದು ಒಳ್ಳೇದಲ್ಲ, ಬಿಟ್ಬಿಡ್ರಿ ಅದನ್ನ. ಇದು ಇನ್ನೊಂದು ಕಂಡೀಷನ್ ಒಳಗಡೆ ಬರೀ ಕೆಳಗಡೆ ಮಾತ್ರ ಹೋಗ್ತಾ ಇದೆ, ಅದು ಒಳ್ಳೆಯದು. ನೆಕ್ಸ್ಟ್ ಒನ್, we could able to do this one both by experiment and also mathematical model which will be produced. Next, yeah, we could able to even do a transient of the one and then see within few flapping cycle it will produce a consistent lift if it is on a green line, which is asymmetric flapping. If it is on a red line, you don't get any net force as such. ಕೆಲವು ಟೈಮಲ್ಲಿ ಮೇಲೆ ದಬ್ತೀರಾ, ಕೆಲವು ಟೈಮಲ್ಲಿ ಮೇಲೆ ದಬ್ಬುತ್ತೆ, ಕೆಳಗೆ ದಬ್ಬುತ್ತೆ, ಅದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ನಿಮ್ಗೆ ಯಾವುದೇ ರೀತಿಯ ಲಿಫ್ಟ್ ಬರೋದಿಲ್ಲ. If it is on the red line, that's what we could able to show. And other thing we saw is that birds not only do up and down motion, in nature also if you see Gauss's book, downstroke is always faster than the upstroke. That is in the nature also true. Second thing nature also does is that while going down, they stretch it like a flat plate, push the fluid down, that's the air down. While coming back, they bend it and take it up. Okay? That means the shape of the thing on the downstroke is very different from the upstroke. If I can impart that flexibility into the wing, what would happen to my lift generation? Okay? Which we did a mechanical model. Next one, where in which I show an animation. You can see that while going down it goes like a flat plate, while coming down it bends itself and come up. Okay? If I do mimicking what a bird does, my lift generation, next lap. Okay, next one. Almost if you have to tune it, where to flex it, what to do, you have to do the adjustment. We can almost double the lift generation by introducing this flexibility into the wing. Next one. And these are some simulation, experimental things to compare with our this one. Next one. Yeah, these are mathematical things. Basically, I am trying to say that there are various elements you can go on fine tuning to increase your benefit. Next. Then after doing all these things, we produce this kind of a graph, like your teacher will ask, with angle, what is the dispersion, whatever he was telling, what is the scattering efficiency. Okay? Same way we can also generate for varying Reynolds number, it's one non-dimensional number, like speed of the size of the wing, speed of the thing, how you can change your lift generation as such. Next graph, and go next. And we can generate a graph like this, okay, which will tell you with the downward frequency and the size, what is the best you can get for a given object. Okay, these are called design plots, which you can use it for designing microwave vehicle kind of an object. Okay, this is the result. And a student is basically building a small test rig. He is come as an intern from IIT Bombay. He helped us to within the Abhay. Okay, which we use that one in the lab, and then essentially we try to measure the forces using this object, which is what I presented. Next one, I would like to indicate different size of the wings are attached to that test rig, and then I measure the forces. We do detailed experiment one side, simulation on the other side to get one-on-one correspondence. Okay, I am at the end. I believe I could able to convince you people that it's one example where in which it is connected to the nature, and also I try to tell you a systematic study to understand and extract the useful part and then use it as a design tool. Okay, this is what is the one story what it can go. Okay, hence I believe you people are able to understand how the research goes, how you identify a problem at a certain level, and doing all these things, it also requires, next slide, money and support from the various agencies who are interested in. For example, fog prediction, airport was interested, and geological and other formation, it's a fundamental research, my institute supported it. And for this kind of application, both defense and US Air Force and other many people have funded this project. And I'm happy to take any questions if you have anything related to bird or insect flight or fluid dynamics research or anything. If you don't have questions, I'm unable to convey anything to you, or that's what I will believe.